So we have a conical water tank that is 18 feet high, has a radius of 12 feet, and is filled to a depth of 15 feet. So the first thing we'll do is we'll draw our tank. And we know that it has a radius of 12 feet. So there's our 12 feet. Has a total height of 18. And the water is 15 feet deep. So anytime we're attacking one of these problems, easiest way is to start by making a slice. And we choose that slice so that the sides are straight up and down. We don't worry about the angle for right now. Now, what we know is that we can find the volume of that slice because it's the shape of a cylinder. Well, let's get some labeling in here. So let's give that a height of delta H because it's arbitrarily thick. Eventually that's going to go to 0. We need a radius. So it's going to get a little tight here, but we're going to have a radius in here. Let's call that R sub I. And now we can get the volume of the ice slice in terms of our labeling. It's a cylinder, so it's just going to be pi times R sub I squared delta H. Problem is we got an R sub I and an H, so our variables aren't matching up. So we need to add a little something to our drawing. And I'm going to add in right there, I'm going to call that the height of the ice slice. Now the advantage here is if I draw a line all the way up, if you notice what I have here, I've got two similar triangles. One triangle inscribed inside another triangle. So I can make a relationship now. In fact, R sub I is to H sub I, as the radius of the big one is to the height of the big one. And I want to solve this for R sub I. So I can reduce this. This reduces down to 2/3 and cross multiply that H sub I. And there's my R sub I in terms of H sub I. So I'm going to replace what I have in the parentheses here. So pi times 2/3 H sub I, the quantity squared, delta H. Now, one thing I see happen a lot, when you square this, make sure you square both pieces. So the 2/3 gets squared. It's going to be 4/9. So we might write that out front as 4 pi over 9 H sub I squared delta H. So we have the volume of the ice slice, and even better than that, we have it in terms of H. So we're ready to move on and get the force on the ice slice. Well, all we need to do to get the force is multiply the volume by the density because we're already in feet, and pounds is a force. So we're going to multiply the 4 pi over 9 times the density of water, which is 62.4 pounds per cubic foot, H sub I squared delta H. I like leaving it as delta till the very end. The rest I can always do with a calculator. All right, one more important step before we set up the integral, and I like to do the work on the ice slice. My constant's going to hang around. It's going to be 4 pi over 9 delta. The H sub I squared is going to hang around. What I need is the distance that I'm going to move that slice. That's that distance from here to the slice. Now we know this distance is H sub I. We need the whole line is 18, so this guy is 18 minus H sub I. So that one slice is getting moved out a distance of 18 minus H sub I. It's making the definite integral that's going to cover all the possible slices. So the work being done here is 4 pi over 9 delta. You'll notice we'll drop the sub i's because we've gone to the continuous case. And we'll write dH instead of delta H. Now our limits. Maybe wondering if it's 0 to 15, 0 to 18, how do you know? Remember that we're looking at slices of water, so I can only integrate over where I have water, which is from 0 to 15, and there is my definite integral that needs to be solved. Now what I like to do is pull out the constant. Again, I can always take a calculator and multiply this stuff in later. Here's where the actual calculus is coming in, 18h minus 18h squared. Sorry, I lost my square there. 18h squared, and this is going to be an h cubed dh. So we actually have a pretty easy antiderivative. 4 pi over 9 delta. We're going to have 6h cubed, the antiderivative of 18h squared, minus h to the 4th over 4 from 0 to 15. Now we really don't need to worry about plugging in the 0. It's going to zero everything out. So we get 4 pi over 9 delta, and then we plug in our 16. 6 times 15 cubed minus 15 to the 4th over 4. And if we multiply everything together out, now's the point where we can go ahead and introduce the calculator. We get that this comes out to be approximately 661,619.4, and the units on this are foot-pounds.